Okay, so thank you, Federico. So now, as I mentioned before, we are going to go through a very comprehensive overview of the technology being developed. What I will show you is a video that shows the number of technology that we have developed in a number of scenarios. So first of all, let me briefly recap that in the context of Briseide, we had to develop, first of all, we had to deploy in a very quick manner by using existing technology, standard SDI, so to say. And to do so, we decided to use technology from Integraph. In this case, you are seeing the portal from Integraph, which has been customized for the use of Briseide. And that was just required because we needed to have an infrastructure to start with so that the final user could immediately upload their data, make the ingestion part, check all the metadata, and as soon as the new metadata profile was available, then again adapt all the information and check that everything was consistent. So to start with, we developed this portal, we deployed this portal, we customized it to make sure that it could fit the requirement of the project. And as you can see from the video, it basically allows standard access to geographical information, spatial temporal information to some extent, through the use of a number of features. You can search for relevant information, you can access and connect to the services available through the SDI. You can change, for instance, coordinate reference system. But as we're running slightly in delay, let me jump to the main development of Briseide, so that it becomes more interesting. So you can also access time-rich data. And that was very important for us, so that again, you can see that through the slider you can access, in this case it's WMS information of the island of Hvar in Croatia, and in a very user-friendly manner. So that basically concluded what we needed in terms of basic access to standard information. But that was, of course, enough. So starting from the, let's say, bottom up, we developed the geoportal itself of Briseide. So not the infrastructure that you have seen before, but the geoportal that becomes public is a public result of the project. And as you can see now, the geoportal of the project is made as a standard WebGIS interface. On the left-hand side, you have the mapping part, well, the mapping window, and then on the right side, you can have access to the cataloging. So if you move to the catalog view, then you can see that you can perform searches of the catalog, register to CSW services, and perform queries over the services available to Briseide. You can also add new services, point to new CSW services, and perform the sort of query that you would expect to. Let me again jump a little bit forward. And then as soon as you find the services that you are interested in, then of course you can see the bounding box of the dataset of relevance, and whenever you want, you can have access to additional information that might be available for a specific dataset. Most notably of all this is done over spatial temporal information. So the search is not only performed on a spatial basis, but also on a temporal basis, so that you can filter information that is relevant to you also according to time. And this will see that it will become extremely important in the last part of the video. So basically, this is the geoportal, and the geoportal has been developed by extending the geoportal, standard geoportal with the time functionalities, and that complements the client that we are going to show you in a minute, that provides you access through the full set of functionalities of Briseide, including the simulation part and the sensor part. So again, through the geoportal you can have access to information you need, also accessing the XML, or you can also print out information that is interesting and relevant to you. But let me jump on again on more relevant features. Again, you can see here that you can perform, you can access various services. And as you would expect, you're able to select a feature of relevance and extract additional information on each of them. for each of the layers, as usual, as you can expect, you can either inquire information on the various feature, or you can also change transparency of the various data sets, or perform transformation in real time. For instance, assuming that you have a layer that is on a different, is being encoded with a different EPRCG code, then as soon as you add it to a stack of existing layers, and then the system would automatically reproject and show them in a consistent manner, as again you would expect that. And you will see this in a second. So, as I was mentioning before, and as Federico was showing you, the idea of the GeoPortal is that you should also be able to see temporal information. So again, the standard functionalities were extended to provide support for time information, so you can access information, in this case methodological information, through a slider that allows you to filter the relevant data set of interest of yours. And this is done interactively, basically, as a standard WebGIS would do, but this is done not only with spatial data, but also with temporal information. So in practice, what this GeoPortal does is the basic set of functionalities that you would expect from a standard WebGIS application, but it also supports time. So that's the added value. This couples with the catalog that Federico had shown before. So we can see like now, you can perform queries, and then again, queries can be performed either in the standard manner, or you can also specify the interval of interest. And that's something that is very important. So at the bottom of, you can see that the user can identify dates of relevance, and then once the query is launched, then of course the catalog would return only those information that are relevant time-wise to the user. And as soon as then you select one of the data set of interest, then you can get all the additional information you would expect. And as Federico was showing before, again, these only refer to the temporal extent that you had specified within your query. So that's again very beneficial because it fits well with the existing repository and with GeoPortal on the other side. So these are the two, let's say, web-based front end that represents the first achievement of the project. Let me jump on to the client, because that's something that I'm very keen on showing you. That's, again, probably the most visible achievement of Briseide. So what we have done is that, starting from the technology that we have developed, we have provided support for spatial temporal information through a 3D interface. That's something that was considered, again, very important for the final user. So what you can do, you can specify the address of WMS, in this case WMS T services, and then select the resources that is relevant to the user. You can see it on the right hand side, so it all fits with the previous picture. And then this information is automatically shown within the 3D globe, so that the user can then fly to the area of interest and change the parameters of the time parameters. So in this case, retrieve the parameters regarding the area of interest, but it can also change the time bar, so that the various resources available interactively change over the 3D scene, and the results are immediately available to the user. So it becomes, again, much more streamlined and much more user-friendly for the final operators to access temporal information. And this approach actually represents the front end of shows the front end of the services that on the back end were developed. So that was as far as WMS T, with T is time, not transactional, is concerned. And then we move on to WCS coverage. So similar approach, the user would select the service of interest, and again, this is done in a pretty straightforward manner. The address can be typed in by the user, and then as soon as these are it's just a list of the most recent services. Then again, the user, once the interrogation is sent to the server, the service returns back all the capabilities, of course, so the user can select the layer of relevance, and then once the layer is selected, then the relevant resources can be selected through this interface. And as usual, all the relevant information, for instance, the coordinate system views as well as supported format and so on are always easy to see from the user. And then as soon as the relevant information is selected, then the final query is sent to the system and the results are shown both in 2D and in 3D. That's a warning that tells the user that this information will be loaded also in the memory for the user within the 3D interface. And as you can see, basically, the 3D client that extends UDIC has an additional set of graphical components that can be used to render the coverage information in this case. So as soon as the user flies in, the information is rendered in a number of different ways. You will see that you can decide the type of visualization that you're interested in, for instance, from image to vector lines. You can see that these are vectors showing the various coverage measurement, and then you can amplify the Z so that you can better appreciate the Z extent of the coverage. Or you can also decide to have spatial operators applied on top of those information, for instance, to allow better visualization of the data itself. And you can decide to have it lying on the ground, or to have it flying above, or to switch between different visualization modes. As I showed before, you can use either an image or through vector lines, or you could decide to use patches that can, again, be more useful to help the operator understand what's really going on. Then from within the same environment, you can also access sensor information, in this case through SOS, Sensor Observation Service. As usual, the user connects to the relevant service through this wizard. So once the service of interest is selected, then again, there is the handshake, and then through the capabilities, basically, and then the system goes through a series of steps whereby the user can decide the sort of the type of sensor that is relevant, the devices that he wants to connect to, as well as the type of observations that each of those sensors is providing. In this case, we are selecting all. And the final output of the sensor. So basically, again, we do this through a wizard so that it becomes fairly easy for an operator without any specific knowledge to use it in a meaningful manner. Then as soon as we connect to the service, you can see that the same sort of tools appear at the bottom. So you have a 2D window on top, but most importantly, you have either a table view where you can access all the information coming from the sensor and filter them by type, by name, and then you can also access the 3D view. So as in the previous case of the WCS, you just fly to the area, and then through those sliders, you filter the time slot of relevance for you, and you will see now in a minute that as soon as you fly to the area and change the parameters, these are rendered in real time, so that you can immediately understand what's going on in terms of sensor information. And this is, again, this was considered very, very useful from our final user, in this case the serial protection of the progress of Trento. Now you will see in a minute that the operator will move those sliders, and basically the information from the sensor will be rendered in real time. So again, yeah, that's and those sensors in this case are referring to hydrological disturbances. So they are monitoring station permanently installed to assess sort of major landslides that is affecting that village. And through those sliders, the operator can quickly assess what's really going on. What they are doing now to do the same thing is they are going through an awful Excel sheet and check for outliers or relevant or information of relevance. So you can see how this approach is much more beneficial than their operational activities. Then something again very relevant, the use of NetCDF, as was mentioned before by Federico. So basically support for multidimensional information. You have this simple interface at the bottom of the client where you can associate to each of the dimension, X, Y, Z, the proper measurement of relevance. So in this case, we associate to X and Y, latitude and longitude, and then we associate a given measurement to the Z, so that it can be shown also in real time. In this case, we are showing wind tides, I think, the wind direction at the globe level. And as you can see, this is immediately rendered in 3D, and then through the slider you can change the interval of interest, and the operator can also change the representation of the information. So again, as I mentioned before, it can be either rendered on top of the 3D scene, or the operator can decide, for instance, to replace with a pure vector information or with patches. And for each of those visualization means, you can always change the scale of the Z so that it can amplify features of relevance, change the way those features are rendered, in this case through lines, but the operator can also decide to render them through patches. And all those components that you have seen before actually are being integrated into a meaningful client. So you're seeing now what's the sort of update of the project, a sort of real-time update of the project, but in the end, once the development stage will be finished, the operator will have all the functionalities that we have mentioned so far available through a single interface, which is the 3D client, and the very same set of functionalities available through the GeoPortal. So that's the double result of the project. And we will make this available to the community, so that also other operators are involved or are interested in the achievements. They can also be involved with us in Briseide. So that concludes this part, where you see the first technical results of the project in action, and then I will leave the floor to Dragan so they can conclude with a more business perspective to speculate on the impact of those technology on the market.